Hello everyone. In this video I'm going to be looking at finding the inverse function of a more complex expression. In this case one that has two variables in it. I have 2x plus 3 over x minus 1. So with this process I'm going to follow the same general process as I would to find any inverse. Though I'm going to use more algebra to figure out the final product, as I have to, as I said, go from two variables that I have down to one. So let's get started. First thing I'm going to do is I will rewrite this with a y equals. So instead of f of x, it's now y equals 2x plus 3 over x minus 1. Next, and this is an interchangeable step, I'm going to switch my x and y. Just literally trade places. Now, one option you have is now I'm going to solve for y. If you didn't switch your x and y, because you can't do it at the very end of the problem, you would instead solve for x. But in the case that I'm doing, I'm going to solve for y. The first thing I need to do is get my y expression out of the denominator. So in other words, I want all of my variables for y, since that's what I'm solving for. I want them all to be on the same level. In other words, nothing in a denominator. So to do that, I will multiply each side by y minus 1. And now, over here, I'm going to have y minus 1 times x equals 2y plus 3. Again, since I'm solving for y, I want to get y out of the parentheses. So I'll distribute my x, and so now I'll have xy minus x equals 2y plus 3. So from this, I want to solve for y. So let me give myself some more space. So if xy minus x equals 2y plus 3, just double checking. Again, my big dilemma with a problem like this is I have two variables for y. And if you were solving for x instead, you'd be facing the same problem. First thing I'm going to do is move all my y terms to the same side. And I'm going to move the 2y over, which means I'll subtract. And I want only my y terms on a single side. It doesn't matter which side, I'm just choosing the left. Which means I want to move this single x. So I will add x to both sides. And when I do both of those operations, on my left hand side I'll have xy minus 2y. The single x on the left is now gone. It's over here on the right. Now I have x plus 3. So again, these canceled, I'm left with xy minus 2y equals x plus 3. Now since I have both of my y terms on the same side, I can go from two variables to one by factoring out the common term. So now I have y times the quantity, x minus 2, x plus 3. And this is where I want to go. Now I have gone from two y values down to 1. Now I can solve for y by dividing by the quantity x minus 2. And it leaves me with y equals x plus 3 over x minus 2, which I can't reduce anymore. Don't forget, if you're thinking, well, couldn't you cancel out the x's? And the short answer is no. I cannot, because they're separated with the 3 and the 2 by addition and subtraction. If it were instead 3 times x over 2 times x, then yes, I could cancel out x's. But again, because it's plus and minus, the x's are going to stay the way they are, and I've simplified this as much as I can. My last step is going to be to write it in proper function notation, inverse function notation. So inverse f of x equals x plus 3 over x minus 2. So with a problem like this, I want to switch my x and y. isolate my variable. In the case that I did, I isolated the y. And when you have two variables, the thing to do is get all of your, in this case, y variables on one side, factor out your common term, and then continue to solve for y.